Hey everybody, it's Mr. Snyder here. I'm here to talk to you about the vertex form of a quadratic function. So a lot of this stuff on the front side of this page is stuff that we've already done before in Chapter 1. I'm just going to go through this sort of the front page sort of quickly, and then there's some new stuff on the back side. So Chapter 4, we're going more deeply into the vertex form of a quadratic. The vertex form of a quadratic, the general form looks like this, where the values of a, h, and k are going to be different numbers depending on what type of quadratic we're dealing with. So remember, the vertex here is given by the h and k values. And the axis of symmetry is just the h, or the number that's being subtracted in the bracket, tells me that axis of symmetry for the parabola. As you remember, the direction that the parabola is opening depends on the a value, and if the a value is positive, it's opening up, and as you know, if the a value is negative, it's opening down. Right? So let's see what we remember on this table below. So remember, the equation is x minus h squared plus k, right? And so because it's, in this first example, it's x minus 2, that means the actual vertex is at positive 2 and 1. If the vertex is 2, 1, the axis of symmetry was x equals 2. The direction of opening here is up because the a value is positive. In this case, the number of x-intercepts, well, if we sort of like draw a little picture of it, it makes more sense to us. In this case, the vertex is at 2, 1, and it's opening up. So if the vertex is above the x-axis and it's opening upwards, there's not going to be any x-intercepts. And the domain and range, for all quadratics in general form, the domain can be anything. In this case, the range could be or equal to positive 1. Let's look at the second example. In this case, the vertex is given by the hk values, so that would be, in this case, negative 1, because it would have to be x minus negative 1 to give me x plus 1 in the bracket, and 5. Axis of symmetry is just the x component of my vertex. In this case, it's opening up because the a value is positive. This is a situation where, again, because it opens upwards and it has a vertex up here, it's not going to have any x-intercepts. And the domain and range, the domain can be anything. The range is anything where the x is greater than or equal to 5. Next equation
Can I have the custodian call extension 219, please?
In this case, my vertex is going to be 4 and negative 8.
Karen Craig, call 219, please, Karen.
Again, the axis of symmetry, I can get that just from where the vertex is. I know it's opening down because in this case the a value is negative 2/3. In this case, because it has a vertex down here somewhere and it's opening downwards, again, there's no x-intercepts. X can be anything in the equation, still get me an answer, but the y values will be restricted such that the y values are less than or equal to negative 8. Last one looks a little bit different because there's nothing written at the end here. So the fact there's nothing at the end, if we want to, we could think of that as saying like plus 0. The vertex here then would be negative 5, 0, where the axis of symmetry here is x equals negative 5. It's opening down because the a value is negative 3. I think about what this one looks like. It's got an x-intercept here. It's opening down, so it's going to look like this. This is a funny situation where it actually hits the x-axis but doesn't cross right through it. So in this case, there would be one x-intercept right at -5. The domain, anything, the range is y is got to be less than or equal to 0. All right? So that's a review, but it's something that we probably could stand to sort of like practice again with the things in that on that table. All right? So flip over our page. There's a couple things on the back. First thing, how many quadratic functions are there with a vertex of -3, -6? Well, if I sketch it out here, -3, -6, the vertex there. So it might look like this. There's a quadratic with the right vertex. But that's not the only quadratic that would have that same vertex. I could draw one that looks like this. I could have one that's opening downwards. So there's many quadratics that will have the same vertex. So just the vertex itself isn't enough information to know for sure what quadratic you're dealing with. It sort of depends on the A value. To determine whether it's opening.
Ms. Melrose, call 221, please. Ms. Melrose, 221.
Up or down, and determining whether it is sort of been stretched or compressed vertically. So what we're going to do is we're going to actually figure out that A value. To do that, we're going to use the vertex and another point. So any point other than the vertex. And we did something similar to this to find the A value when we were dealing with a factored form of a quadratic. Now we're going to do it with a vertex form. All right. So this is saying, find the equation of a quadratic function with a vertex that goes through this, that goes through a point. So now it's giving me an exact point that it's got to go through. You don't need to sketch it out, but just to give you a visual here, what I'm saying is, it's going through that point, it's got the vertex through that point, -3, -6, and it's going through the point -1, 2. So it's got to go through this point here. In order to do that, it's going to look something like this. I can sort of see visually that the A value is going to have to be positive for it to get to that point, but I need to be able to actually calculate exactly what the A value is. So the way I'm going to do that is start off with my equation that looks, and put in the vertex. I'm going to step 1. Sub my vertex into the equation. Step 2. What I'm going to do now is I'm going to sub in another point. For the x and y in that equation. Once I've done that, now I'm just left with an equation with just the A value. I can solve what A value makes that true. So in this case, my x is for another point here is -1, and my y is 2. So I'm going to sub those in. So sub in 2 is equal to A times -1 plus 3 squared minus 6. Now it's an equation that I have to just solve. So 2 equals A times 2 squared minus 6. So just be careful with one thing. This is saying A times 2 squared, so A times 4. I'm going to do an extra line here. So I'm going to actually write that out as 2 equals 4A minus 6. And the reason why I'm doing that is because for some reason, A times 4 looks a little bit more confusing. We're used to seeing it written as A 4A. So to finish this off, what I'm going to do is now just get my numbers on one side by adding 6 to both sides, and I get 8 equals 4a. Divide both sides by 4. My a value is going to have to be positive 2 for this to work out. Alright, so my equation is going to be y equals 2, x plus 3 squared, minus 6. I guess my last step here would be sub in the a that I figured out into what I had in step 1, where I just knew what the vertex was going to be. Right? And now that's the equation of this in vertex form that has the vertex here go through that point. Right? Last thing that we're going to do is write out equations in standard form. That's not as bad as the process with example 2. What we're going to do for that is just expand them out, which we've sort of done already. If I have this situation, I'm going to multiply up my brackets. X minus 2 times x minus 2 just by FOILing it out would give me x squared minus 2x, and minus 2x gives me minus 4x. Negative 2 times negative 2 is positive 4. Multiply this 3 into the bracket. That becomes 3x squared minus 12x plus 12. And then I have that plus 1. So the last step here is actually now I can actually collect out my numbers. Notice I didn't multiply the 3 by the 1 because that wasn't in the bracket, but now I can collect up the like terms here and get to a final answer of 3x squared minus 12x plus 13. Now it's in standard form, which is sometimes useful. Last example, same thing. I'm going to just leave that negative out front. X plus 5 squared means x plus 5 times x plus 5. When I multiply up x plus 5 times x plus 5 through expanding, I got to that. So then I just take the negative of everything in there, and I get negative x squared minus 10x minus 25. That's the examples for today. These are the practice questions. See what you can get through. We'll talk about problems on Friday. I'll probably go over this process again on Friday, but I'm hoping that we're good with questions like numbers 4 and 6 at least on our own, and I think you can try and do pretty well with 8 and 9. Hey, have a good day.